Hi, my name is Karthik. We are from Group 18. Our subject name is Dynamic and Vibration. Our lecturer name is Dr. Fadila Binti Abdul Aziz. This is our team. Myself, Karthik. My meeting number is B11251041. Dayanidhi Karuna, Analaki Kanagaran. Kailash Analaki Parameswaran. Niraj Analaki Kumarasamy. Rashwin Analaki Jayakumar. Introduction for the subject. Dynamics is the branch of mechanics that study the motion of object and the force that causes that motion. In this application, a crate is pulled across a smooth horizontal surface by an applied force. By using Newton's second law of motion and the equation of motion, we can determine the acceleration of the crate and its velocity of a certain period of time. This example demonstrates how force affect the movement of an object in practical engineering and industrial situations.
Question 18. Application horizontal motion with applied force. A 40 kg crate is pulled horizontally by a smooth floor by a force of 120 Newton. Determine the acceleration of the crate and the velocity of the 5 second if the crate starts from the rest.
Hi, I'm going to talk about problem solving overview, what the situation means. Horizontal motion with applied force means an object is moving in a straight line while a force is acting on the same direction or opposite direction. This force changes how the object moves. It can make it speed up, slow down, or maintain motion. In horizontal motion, several forces actually act together, which is applied force, the force you push or pull with, friction force, the opposite force, normal force, act upward from the surface, weight, acts downward due to gravity. The net effect on these forces decided the motion. This concept is used in many real life situations, such as moving boxes in warehouses, pushing cart in supermarkets, car acceleration on a road, conveyor belt system in a factory. This problem is related to Newton's second law. The motion is converted by F equals to ma, where F stands for total force after balancing friction and other forces, m equals to mass of the object, a equals to acceleration. If applied force is bigger than friction, object accelerates forward. If equal, which is constant speed, if smaller, it will slows down.
The problem statement given in this question is M is 40 kg and the force given is 120 Newton, and since we have smooth floors there is no friction, and the T equals 5 seconds, and since we start at a stop, the initial velocity is 0 meter per second. So with the given information we can find the acceleration by dividing 120 newtons with 40 kg. We get 3 meter per second square. And to find the velocity, we use the formula v equals to u plus at, where u is our initial velocity, a is the acceleration, and t is time. So v equals to our initial velocity is 0, so 0 plus our acceleration times time, which is 3 meter per second square and 5 second. So we get 0 plus 3 meter per second square times 5 second, and the final answer for v we get 15 meter per second.
Question 39. A machine pulls a load with a force of 900 Newton. The load moves at a velocity of 2.5 millisecond in the same direction as the force. Determine the power developed by the machine.
So, what is power? Power is rate at which work is done or energy is transferred. It tells us how to quickly a task is completed, not just how much work is done. In physics, power is calculated as work divided by time. P equals to work over time, meaning that doing the same amount of work in less time requires more power. For example, two machines may lift the same load, but the one that lifts it faster has higher power. In everyday life, is seen in engines, electrical appliances, and human effort, where the speed of doing work is what makes power important. For the opinion of the James Watt, also telling is Power is understood as how quickly a machine can perform work, which is why he improved steam engines to measure and increase efficiency. For the opinion of the Lord Kelvin, he also tell about power emphasized in terms of energy, transformation and efficiency, highlighting that not only the amount of energy matters but how efficiently it is converted from one from to another. So both of them are telling the views is show the power is show of the power is not just doing by the work but about how efficiently and quickly that works is carried out in real system.
Problem statement: force F equals to 900 Newton, velocity V equals to 2.5 meter per second. Force and motion are in the same direction. So if you see there's a crane lift up a crate in y-axis. So the Newton, as we know, 900 Newton, and we got the velocity which is 2.5 meter over second. So if we follow the formula to find the p, the formula is p equals to f times v. So we know the f and v. So we times both numbers and we get p equals to 2250 watts.
So the third question is the 150-pound skater passes point A with a speed of 6 feet per second. Determine his speed when he reaches point B and the normal force exerted on him by the track at this point. Neglect friction. So the objective of the question is determine the velocity of the particle at point B and the normal force acting on the particle at point B. The solution for this question is in the question they already given the point A height is 20 feet and the point B we have to find that point B is x equals to 25, so the y square equals to 4 times 25 is 100, so the y is 10 feet. So the next part is we have to find the velocity at point B. So we have to use this equation v square b equals to v square times a plus 2g is which is gravity times weight height a minus height b. Then we get the velocity b is 26.1 feet per second. After that, we have to use the curvature formula to find the curvature value. So for that, we need y prime and y double primes value. For find the y prime equals to dy dx, then the y prime value is 2 over y. Then for y double prime is 2 square y over dx. So the y equals to 10. Then the y double prime formula is negative y over y cube. So the value is y equals to negative 0.004. Then the curvature value we can find it lah. So the which is 265.3 feet, which from this value that we got we can substitute in the formula which is the Newton equals to w cos theta minus w over g times with v square over p. Then we find the Newton's value which is 135 lv, which is pounds. Thank you, that's it.